All right. All right, let's switch. All right, hello, hello, hello. Good evening, everyone. How's everybody doing this fine evening? I hope everybody is well. We're here for the second Math 102 class of the evening. I hope everybody is doing great. We're gonna get started here very shortly with some new material. But yeah, doing good, Bill. Good. Excellent, excellent. Wonderful. Did you have a good weekend at least? My weekend, my weekend was a little rough, but I hope you had a good weekend at the very least, Bill. Awesome, dude. I was I got the booster shot and the flu vaccine. So, but my body was in a little bit of a rough shape this weekend. I was like in bed. So I do. Hey, Strolling, how we doing? Good evening to you, Strolling. How are you? Yeah, so what I guess I want to kind of say is I want to apologize to you guys. I said I would update grades this weekend, but I actually was in bed all weekend because of the booster shot and the flu vaccine. So I was like, yeah, I was like the booster for the COVID vaccine and the flu shot at the same time just wrecked my body. So like, I get home after that, and then my body's like, you should probably go to bed because you're getting tired. Next day, I'm super sore. I'm like, yeah, I'm gonna probably stay in bed all day. And then the next day, I had to work, but then I was a little dizzy. I'm like, yeah, I'm probably not gonna be sitting too long in front of a computer. So I do apologize in regards to that, but I will be working on this week on your grades. So I want to at least tell you guys that before we get started. Maritza, hello. Good evening to you. Good evening to you. Sammy, good evening to you. Good evening to you. I hope both of you are doing well. Hopefully you Strolling and Sammy, hopefully you had great weekends as well. Hopefully better than mine. You sent me a message regarding the homework from 9.3 is about the T distribution table. Okay. I probably will have to check my email. Did I even check that today? Oh, maybe I didn't. Was it about like finding a critical value from the T distribution table? Or something like that? I'll have to check that. Ooh. Um, yeah, so it'll depend on the degrees of freedom. Um, that again? Uh, no, that wasn't like that. So. It was not like that, I promise you. That was for, which problem was that for, Strolling? Do you know? I can acknowledge that right now. What problem was that for your homework? You can share it right now. I got a little time. I'll look it up really quick. Where is it? There. Fine, it's no big deal. Just tell me which question on section 9.3, and then I can look that up appropriately. The questions 1, 2, 3, or 4, Strolling. That was okay. Okay. I see. Alright. I see. I see. Was that 1, 2, 3, or 4, Strolling? I want to make sure about one thing. I want to make sure about one thing in that regard. Question 2. Okay. I'll bring it up. Yeah, alright. Maybe check one thing here. Yep. Yeah, so you did 98% and you have a... Yeah, so it should be pretty close, but you have a size of 61. Okay, okay, so that's the big issue there. The big issue is the sample size there. Alright? So you have a 98% confidence interval, right? And that's what you got. So, what we have here, and I just need to make a double extra sure I'm not going cray-cray. 0.01, 239. That, yeah. Okay, that's right. So what you have here is, if you look at the table, yeah, so it's a different critical value, and what I'll need to do is let me switch the camera here for just a second. Okay, because this is what I'm looking at the example here, but I'm just making sure about one thing that they have here. All right, now you have a 98% confidence interval. Now the way it's going to work is we're going to go to a specific page in the textbook here. So if we go to the e-text here, for example, and we do a little bit of a search on the e-text here for just a sec, and then it'll start making some sense. Oh, that's pretty loud. I need to turn that down. You need to be turned down. Oh, turned down. Oh man, it's still loud. Amazing. How does it even happen? Arche. There we go. Alright, so we're going to go to page A14 here. We're going to find this. So page A14 is where we're going to find this specific chart that we want to use. Okay, so what you need to do is it's dependent on the sample size as well. Alright, so one of the things you need to understand is that, yes, you're going to use the 0.02 part here. Alright, so you're going to use the 0.02 part here. But, because again, you do 1 minus 0.02. 1 minus 100% minus 98% is 0.02, right? So you probably got it from that part there, right? I'm assuming that's probably what happened there. So, the thing is, you also need to use the degrees of freedom here, which is equal to 61 minus 1. So you should have this equal to 60. So you need to look at 60 degrees of freedom and 0.02. So probably you might have used the one on the bottom here at 2.054, but because with degrees of freedom that's slightly close, it's again 2.099 as opposed to 2.054. You may have ended up using that instead. So if you want to find the critical value that's associated with it, that's how you would justify that in this case. Okay, now I know we didn't really talk about critical values here in that particular section, to be fair, but again, that's how you would go ahead and find that here. It would be 60 degrees of freedom, but also underneath the 0.02 for the 98% 98% one there. Does that make sense? Let me know if you're not sure. Any questions about that? That's page A-14. So do a search in the text, do a search in the e-text trolling of A-14, and then you'll have access to this page. All right, cool. All right. All right. Well, ladies and gentlemen, we are going to get started here for today. Let me switch back to my other cam here. We'll come back to this guy in just a second. Okay, so let's do some intros here, and let's get started with stuff. All right. Okay, let's get started today. Welcome back to Tuesday. Hope you had a nice weekend. All right, so today, ladies and gentlemen, let's go ahead and discuss what is going to be happening here today. Today, we're going to be finishing up Chapter 10. All right, we're going to be finishing up Chapter 10 here today. It'll be Section 10.3, so that's what's on the docket here for today. Now, just as a friendly reminder here for you guys, we are going to finish up Chapter 10 here today, and then our next section that we're going to do after this one, the one we're going to do on Thursday, will be Chapter 4. Okay, so Chapter 4, we're going to go from Chapter 10 to Chapter 4. All right, so Chapter 4 is going to be the last chapter of the textbook. Okay, so we're getting very close to the end. Again, Chapter 10 to Chapter 4, that is the goal, that is the story, that is what we are doing, question mark with things. All right, so that is the thing that is going on here. So just to let you know, hey, this is what the story is moving forward. Again, I do apologize for not posting your grades here, as explained earlier. And I was suffering from the effects of getting my shots there, so stayed in bed for a couple days. Finally back up to 100% today, so I will be getting that done during this week to do that. So we'll get that done. All right. So today we are going to continue moving forward here in Chapter 10. We're doing some more hypothesis testing. Okay, that is what the story is for this last section in Chapter 10. All right, so which is Section 10.3. And let's go ahead and take a look at the big board. And let's see how we can get on with it. Okay. All right. Okay, let's do that. Okay. So let's take a good look here about what we're going to be covering here. This is going to be Section 10.3. We won't be doing 10.4 here. Again, Math 120 in this class share the same textbook, so it's pretty common to see the same stuff over and over. But 10.4 is not what we're going to be doing here whatsoever. In any case, more importantly, we are going to be talking about... oh, goodness me. Come on. Brain, you're not working right. All right. There we go. Okay, so let's talk about question number 1 here. What assumptions must we make to do a hypothesis test of a population mean when the population standard deviation is unknown? All right, so here's the story behind this section. This section here is going to, as you see here on the screen already in the notes, is going to revolve entirely around the population mean. We're going to do comparisons on the population mean and hopefully establish a conclusion based on the hypothesis revolving around that one statistic. Now, in order for us to do that, of course, we're going to need to look at some certain assumptions and, of course, at some certain pieces of data in order for us to go ahead and figure that out. Now, the first question here talks about what assumptions. So in order to do the hypothesis testing, we have to have some assumptions here. Now, these assumptions are nothing different than what we talked about here in the previous section. Not much, not by much. So first of all, there must be a simple random sample or a randomized experiment. So that's the first assumption. Again, every part of the sample has to have an equal chance of being selected. We're totally randomized in nature. Letter B, the sample has no outliers. The population from the sample is drawn normally from a normal distribution, or n is bigger than or equal to 30. So we have to have a sufficiently large enough sample size. If you have 30 or more, that's sufficient. If you have no outliers, it's also sufficient. Or again, if the population is small, maybe it's 10, 15. As long as it's drawn from a normal distribution, you're just perfectly fine. All right, and letter C, the sample values are independent. Again, the sample, like people or items, they have nothing to do with each other. They don't influence the outcome of each other, so that's fine. All right, now let's take a good look here at the meat potatoes of what we're going to be talking about here today, is performing the hypothesis test. So question 2, how do we perform a hypothesis test using the p-value method when the population standard deviation is unknown. Okay, so just like we discussed here last time, we're going to have the same first three steps that we discussed when we did hypothesis testing. So again, step one, we're going to talk about first the null and alternate hypotheses. Now, as you can see here on the screen, the first thing that we're going to acknowledge is that, again, our null hypothesis is going to revolve entirely around the population mean. Okay, so we have mu here is equal to the population mean. So again, be on the lookout in the problem. You'll be given the population mean here in the problem. You'll need to identify that, and that's going to be our null hypothesis. Our alternate hypothesis is if, again, it is less than, bigger than, or not equal to that population mean. Again, reflecting left, right, or two-tail respectively. So just like we did last time, one of those three has to be true based on the claim that we're making. Step two, we just say, hey, tell me the type of test, all right, from step one. All right, so we just state the type of test, so that way we have that in our back pocket as we work forward with the problem. And of course, step three, we're just doing the first three steps here to start with. Again, we're going to state the level of significance. Remember, the level of significance here, just given to you in the problem. You don't need to find it. It'll just be stated. Okay, let's look through this carefully here. Let's start with an example. We'll do the first three steps, then we'll do the latter three steps after that. All right, so let me, oops, I don't have it open. Oh, did. There we are. All right, so let's go through a book problem here. Okay. So let's look at number 13 here that you can see here on the screen. Let's do it together. Let's go over all the steps. All right, so let's read this together here. Number 13, ready for college. The ACT is a college entrance exam. ACT has determined that a score of 22 on the mathematics portion of the ACT suggests that a student is ready for college-level math. To achieve this goal, ACT recommends that students take a core curriculum of Algebra 1, 2, and Geometry. Suppose a random sample of 200 students who completed the course set results in a mean ACT math score of 22.6 with the standard deviation of 3.9. Do these results suggest that students who complete the core curriculum are ready for college-level math? That is, are they scoring above 22 on the math portion of the ACT? Okay, so let's go ahead and talk about the null hypothesis here first. If we talk about the null hypothesis here, we want to talk about the population mean. All right, that's what that symbol means, that little U. All right, so the question is, what is the population mean? What is the population mean equal to here? You tell me what number is the population mean equal to here in this problem? Let me know here. What is the population mean here in this case? Uh, 226? Wait, 226? Where's that? 226? Oh, you mean 22.6? Oh, okay. I had to look at that for a second. I'm like, wait, where did 226 come from? I made this bigger. I've zoomed in. It says 22.6 here on the screen, I promise you. I don't know how much bigger, more bigger I can make this. See. This time, can't say I didn't make this bigger. I did. And I made it slightly bigger here. I can zoom in all the way in. This is as far as I can zoom though. There. That's as far as I can zoom. I can't go any further than this. Alright, so 22.6. So what I will say in regards to that, regardless, is remember, this is the population mean. Remember, 22.6 here talks about, it says the random sample of 200 students. So that talks about the sample of 200 students, not about the population mean here. That's just within the sample of the 200 people that we studied over. So what is, if 22.6 is not the population mean, what is the population mean? What is the population mean here then, if 22.6 is not the answer here? That can't be 200. 200 is the sample size from here, Maritza. I want you to read this problem carefully, please. Remember the question that it's asking here. Please read the problem carefully. We're not talking proportions here, Strolling. I'm talking population mean. Guys, read the problem carefully. I'll stop right here and be like, all right, we're not reading the problem carefully for number 13. I will stop. I want you to look. What does the population mean here? What does it say we're comparing with? That's going to be our population mean. So I want that number. All right, she says, Strolling says 22. Now 22 is correct. So let's look at this carefully here. All right, it says the ACT determined that 22 gets you college level ready. And they ask you here at the end, says, are they scoring above 22 on the math portion? So if we talk about the population mean, that's what we're going to compare it with. We're comparing it to a score of 22. Okay, so we have 200 students we sampled, said, okay, 22.6 here is going to be, again, that's the sample mean, but that's not the population mean here, which is 22. Okay, you guys remember, you have to read these problems carefully here in order to get the proper population mean. All right. All right. Let's talk about the alternate hypothesis here. What's our alternate hypothesis according to this problem? Is it going to be less than, bigger than, or not equal to? Okay, and how do I know it? Okay, you say bigger. Maritza says is bigger. Strolling says is bigger than 22. And the answer to that is yes. It is definitely bigger than 22. That is correct. Good. Let's put that there. All right. So that is the first step here. Again, you can tell this is bigger because it says, are they scoring above a 22 on the math portion of the ACT? 100% right. Okay, let's go to step 2 here. Okay, so what type of test do we have here in this case? What type of test do we have? Do we have a left tail test, a right tail test, or a two-tail test? We have a left, right, or two-tail here. That's going to be our step 2 here in this case. So. All right, both of you are correct. Very good. A right tail test. Good, good. We're going to make note of that here. All right, so far so good. Okay, now let's go to step 3. Step 3 is stating the level of significance. Again, this is given to you in the problem itself. So let's take a look at that. Again, we're going to use this guy here who says 0.05. So that's going to be our guy here. All right, so far so good. Okay. Any questions so far? Right? Hopefully we got used to the first 3 steps here, because we're going to need this in order to get the rest of this down. That more, but... Okay. Let's take a good look at the big chunk here, which is the last 3 steps here of this process. Let's look at the last 3 steps here. Okay, so we'll go back to our notes. Now, the last 3 steps are pretty much similar to the last 3 steps that we had here from before. But let's talk about, first of all, the first 2, which is step 4 and step 5. The first step here, we have to compute the test statistic. Alright? Now, here's the formula for the test stat, alright? And the pieces that we need here. Now, once again, one of the things that we talked about here last time when we did the other section, section 10.2, we did the test stat here, is we had the calculator find the test stat for us here. And once again, that's exactly what we want to do here as well, okay? So we have the formula here for the test stat, and that's all well and good. But what is going to be important here, of course, is we're going to have, again, if we go through the process of finding the p-value, we're going to also find the test stat here at the same time. However, one of the things that we do have to make note of, though, is key pieces of information here within the test statistic, because we will need those values here specifically. So, for example here, as you can see in the formula here for the test stat, again, you don't need to memorize it, because we're going to use the calculator to find this, but the pieces of the puzzle we do need specifically, for example, it says we need the sample mean minus the population mean. Population mean we already found to be 22, like in this case. We also need the sample standard deviation and the sample size. So that's what we're going to need here. Let's find, again, the sample mean. Again, that's going to be x bar. All right, and then we're also going to have the sample standard deviation. Sample standard deviation, that's going to be S, okay? And then sample size here, which I'm not going to state, but that's N. Okay. So let's find all 3 of these according to our problem that we have here. So let's take a look at the problem here together. All right. And why don't you guys tell me, what is our sample mean, sample standard deviation, and sample size? So what's our sample mean, sample standard deviation, and sample size? What are those 3 numbers here according to our problem here in number 13? Alright, let's take a look here. So Strolling says that the sample mean here will be 22.6. That's true. So no problems there. Okay, so that's our sample mean. We have our sample standard deviation, which is S, which is 3.9. Good. And our sample size, which is 200. Excellent. Alright, so far so good. Okay, so we definitely need these values here. Alright. Let's see, Horitz has got that too. Okay, very good. Both of you are absolutely correct. Nice. Now, what we do need here specifically is we need to write out the test stat here. So let's put the test stat here. We're going to find out what that is. And, of course, in step 5 here, we are also going to find the p-value here. So let's do that here as well. What if I go stronger? What if I get higher? What if I start doing things I know I will regret? I will make All right. So we want to find the test stat here, and we want to find the p-value here. Now, in order for us to do that, we're going to use the calculator here and do the t-test on the calculator to determine the p-value. All right. Now, before we go ahead and do that, everyone, I would like everybody to take out your calculator, okay, because now it's calculator time. And when you have your calculator, go ahead and type in "got it" in the chat, so that way I know you have the calculator in front of you. So it is calculator button presses time. Alright, cool. Alright. I just asked this so that way everybody's on the same page once we go ahead and go through the process, okay? It'll be important. Alright. Anybody else? I don't know how many people are in here, so... Okay. That'll be fine then. Alright. That should be everybody. Okay, so the first thing I would like you to do, everyone, is I would like you to go ahead and hit the stat key. And I would like you to scroll over to tests. So we'll go scroll over to tests. And we're going to go down to number 2, which says t-test. So I'm going to hit 2 and go to t-test. Okay, put that in the chat here. All right, and then go ahead and hit enter on that. Okay, so you should see this sub-menu right here. Old school, new school calculator, doesn't matter. You will all get to this same sub-menu here. All right. Now, at the very top of the screen here, you should see data and stats. Okay, this is what you should see at the top of the screen here. And before we move on here, type in yes if you are at this sub-menu, by the way. Let's make sure that you all are in the same area, same place, if this is what you have on your calculator. All right, perfect. Okay, everybody's here. All right, great. Okay, now, this is very important. At least this part here, what I'm going to mention here next is very important. Now, we have two options here at the very top of this calculator function for t-test. We have data and we have stats. Now, what's the difference between both of these options? What we were given here in this problem, in this example, is we are given statistics. We are given the sample mean, we are given the sample standard deviation, and we're given the sample size. So we are given specific statistics in order to actually solve and find the test stat and the p-value here. So what we want to do is, we want to go ahead and go over stats, and then hit enter, and the stuff underneath should change. So it should change to something like this. Okay, so you should see a little change on your calculator, unless it's already there. It might default to that. Okay, and we're going to go through each one of the values that you see here. So the first thing that we're going to see here is this U0. That's going to be our population mean, which we know from our problem here is going to be 22. We're going to put 22 in that spot, just like so. Next is going to be our sample mean. Our sample mean here is, again, we stated here in step 4 will be 22.6. So we'll put that in that spot there. Now we have SX, which is our sample standard deviation, and that's given to us as 3.9. Okay, so 3.9 here is going to be our sample standard deviation. And our sample size here is 200. Now remember, the last part here is very important. Remember, the last part here that you see is the type of test that we need to put down. Now, we indicated here in step 2 that we have a right tail test. So remember how it goes. It goes two tail, left tail, right tail. Okay, in that exact order. So two tail, left tail, right tail. Now, since we know that this is a right tail test that we indicated here in step 2, we're going to go over the right tail test here, and we'll go ahead and hit enter. All right. And now we're going to go skip the color part here because we don't care. And we'll go down to calculate just like so and hit enter. Okay. So before we move forward here, let's type in, I don't know. Let's type in the letter T. Let's type T in the chat if you got these exact numbers. Okay. Now I'm just making stuff up as I go along. All right. Okay, so all of you got these same exact numbers that you see here on the screen. Excellent. All right. Okay. All right. No problem. So far, so good, guys. So far, so good. All right. I like where this is going today. Okay. Now, let's take a look at the results that we get here from our calculator. We're going to take a look here at the first two numbers that we see here. The first number that we see here, again, the first two numbers is like the same thing, kind of what we had last time here. The first number here is we have the test stat. So this is what this t is equal to, this 2.17 stuff. That is our test stat here. So we're going to write that down. That's going to be 2.1757. It's going to be our test stat here. And then next we have our p-value here, which is given to us here as 0.0154. So we have our test stat at 2.1757 and our p-value here of 0.0154. Okay. Now, once we have these two numbers, we're now effectively done with this. The rest of the numbers here are just stuff that we entered in from before, so no biggie. Now we're going to do the same thing that we did here in the last class last week, again, is to make our comparison. That's our next thing here. We have to make our comparison. And again, we are now going to use our level of significance here. We have to basically, again, compare our p-value that we just found and see if it is less than the level of significance. So, I'll ask the question here, is 0.0154 less than our level of significance, which is 0.05? So a yes or no question here. Is 0.0154 less than 0.05? Yes or no? All right. So the answer is definitely yes. Okay. Absolutely, right? I think everybody would agree. 0.01 is absolutely less than 0.154. 100%. All right. Now the question is, what is our conclusion here? What is our conclusion? We have two possible conclusions. Remember, do hypothesis testing, we only get two possible answers here. What is our conclusion in this case? So if we take a look there at the steps here off to the left, again, we either reject the null and accept the alternate, or accept the alternate and reject the null. And let's see here. We have Strolling saying, and Bill saying, and Horit saying all the same things. Oh, I like this. I like where we're going, guys. All right. And that is correct. We are going to reject the null hypothesis, absolutely right, and accept the alternate. Good. Okay, great. Any questions about that problem? I hope that wasn't too bad. Any questions? That's our final answer for that problem. No questions so far? Okay. All right. Hopefully this has been easy so far. All right. Okay, let's go and do the other example. We do have one more example to do. All right. All right, let's go to, yeah, here we go. All right. So the next question we're going to do here is going to be question number 21. Let's do question 21. All right, waiting in line. All right, so let's read this off here together, and let's see how we can go ahead and do this problem. All right, so the mean waiting time at the drive-thru of a fast food restaurant from the time an order is placed to the time the order is received is 84.3 seconds. A manager devises a new drive-thru system that he believes will decrease wait time. He initiates the new system at his restaurant and measures the wait time for 10 randomly selected orders. The wait times are provided in the table. Okay, so here are the particular wait times. Now, the question that it asks is this: was the basically says, is the new system effective? Is the new system effective? Use the 0.1 level of significance. Okay, so that's what we're going to look at. Is this new system that they're doing to reduce wait times, is this effective or not? Okay. Let's go through the steps and see what we have. All right. First and foremost here, ladies and gentlemen, is we need a population mean. That's first and foremost here. So what is the population mean in this problem? What is the population mean here? All right, Horace says it is 84.3 seconds. Yes, I would agree 100%. That is correct. 84.3 seconds. Spot on. Yes. All right. All right. Now, next, what is the alternate hypothesis here? What's our alternate hypothesis? What is our alternate hypothesis here? Is it going to be less than, bigger than, not equal? Strolling says less than. Remember, it does ask us if the system is effective, so that's what it does ask us here. So the answer is, let's see, Strolling right. Let's see if anybody else has an answer. Alright, so the answer here is indeed, I agree with Strolling here, is less than 84.3. We're trying to make a more effective system, so we're trying to decrease wait times here. So that is correct, 100% right. Alright, good. Okay, so question, what type of test do we have here? What type of test? Do we have a left, a right, or a two-tail test? We do indeed have a left tail test. Good. Nice. So both Horitz and Strolling are correct. Good. So we have a left tail test. And we are given the level of significance here. Let's go ahead and reference that back. 0.1 level of significance. Okay. All right, perfect. All right, now, let's talk about the difference here in this case. Now, there's going to be a big difference here between this problem here specifically and the last problem that we did. Now, the issue with this problem is that in this particular problem for 21, we're given a data set and not the particular stats. Okay, so we're not given a sample mean, we're not given a sample standard deviation. We do know the sample size here, as it is 10 randomly selected orders, okay? That part is definitely true, okay? But we don't know what the sample mean and sample standard deviation are. We just have a data set here just given to us, and that's about it. All right, so we're going to go ahead and go through the calculator here, of course, to find those two things out. And once again, we're going to take the test. We're going to find the test stat here. And we'll also find the p-value at the same time here via the calculator. All right. So let's go ahead and do that right now. So I'm going to cover this up here for just a second. Okay, so we're going to come back to these two guys, but we'll cover that up here for just a moment. And we're just going to use our calculator here in this instance. Okay, hopefully everybody is ready to go with the calculator. Okay, so we're going to go ahead and get started here. All right. Okay. So, first thing I would like you to do here, everyone, is to go ahead and hit the stat key. And we're going to go to edit this time. This time we want to put all these values in our list. So we're gonna go hit the stat key and go to edit. Now, if you have values here in your list, again, go ahead and highlight the list, hit clear, and hit enter. So that way it clears all the values in your respective list. So you can start fresh and new. Okay. Now, let's go ahead and enter in all the values from our data set. And we'll put them in. And we'll see what we get here. Okay, so these are all the values in our data set that need to be entered into list number 1 in this case, okay, in order for us to use as part of the process. When you have all of those entered, please type got it in the chat, and I want to be sure that everybody has this entered into their calculators in their list. Please type got it in the chat once you have this entered in. All right, Porit's got it. See if the others have it. Okay, Bill's good to go. So is Strolling. We will wait for Sanla and Sammy and Maritza. Alright, Sammy's good. Alright, Sanla's good. How about Maritza? Alright, Maritza's got it too. Okay, perfect. Okay, so everybody has it. Excellent, that's good to see. Alright, so everybody's on the same page now. Perfect. Okay, so the next thing I would like you to do, making sure we don't enter in anything else bad in the calculator, make sure. We're gonna hit the second and the mode key. We'll quit to the main screen, just like so, and just ensures that it's saved properly. We're gonna go ahead and go to the stat key here. We'll scroll over to tests. We're gonna go back into t-test number 2. We'll hit enter. Okay, now, this time here, bring up our guy here. This time here, we are not going to be using stats because we're not given stats here, we're given a data set. So what I would like you to do here at the top of t-test is to scroll over to data and hit enter. So we need to scroll over to data and hit enter just like so. Okay, so your submenu here should change a little bit right below that input side. Okay. Now, right below that, we should put in our population mean. Again, in our problem here, that was given to us as 84.3. So we're going to put 84.3 in that particular spot right there. All right. The next part here should be your list. Now, you should, if you don't have anything here, or if it's different, make sure you have that as list 1. So again, if there's nothing there, it should default to list 1, but just in case, you can hit second and 1, and it'll bring up list number 1, and you'll have that in there. Next part here is the frequency. Leave this alone. Leave it at 1. We're not going to touch it, okay? If there's nothing there, put the number 1. We're going to leave it alone otherwise, okay? All right, it'll default to 1, but, you know, not going to change it. All right, and the last part here is the type of test, as we talked about before. Again, on the calculator, it's a two-tail, left tail, right tail test, okay? Again, we have a two-tail, left tail, right tail. Again, in this particular instance, in step number 2, it's a left tail test. So we go left tail here, and we hit enter here. Select that second choice for a left tail test. Got two tail, left tail, right tail. We'll go to calculate here in this instance and hit enter. All right. I want make sure everybody got these same exact numbers here in the chat. So type bet in the chat. Type bet in the chat if you got these same exact numbers. I got the p-value to be different. Okay, if you got the p-value here to be different, let's go back. Let's make sure you have the right numbers. All right, do you have 84.3 here, Horitz? If you don't have 84.3 here, maybe that's what's up. Or again, we could go back to the list here. You do? Okay. Do you have it as a left tail test here, Horitz? Make sure you have that second one chosen. Let's make sure. Ah, okay. The problem was, yeah, don't forget you have to select the type of test there, Horitz. And then go back to calculate there. So select that type of test. Nice, nice. Perfect. No problem, I'm here to help. Alright, so Sammy, Bill, Strolling, Sanla, Maritza, and Horitz. Alright. Good. All of you have now got it. Perfecto. Alright. Let's take a look at our results, and let's see what we have. Alright, so the first number here, of course, is going to be our test stat, like we talked about before in the last example. Same thing, of course. So we have negative 1.3, 102. Okay, is going to be our test stat here, and that's fine, that can happen. Our p-value here is 0.1113. Alright, so going to 4 decimal places here. That's going to be our p-value here for this particular problem. Alright, we're almost there. Let's go to step 6 and now do our comparisons. Alright. So, step 6 here is, again, we're going to compare that to our level of significance, or significance level. So is the p-value here let's put this down here, is 0.1113 less than 0.10? So yes or no, is 0.1113 less than 0.10? No. Alright, so the answer is definitely not, right? That's definitely not true. Okay, so because this is definitely not true, alright, then all we're going to do here is conclude what? What's our conclusion? Are we going to reject the null and accept the alternate, or accept the null and reject the alternate? Which one of those two? All right. Very good. Nicely done. Yes, yes, yes. Perfections. Alright. So we're going to accept the null and reject the alternate. Alright, good. Okay, perfect. Alright. Excellent work. Alright, any questions? Any questions about that example? Nope. Alright, great job. Alright. So that will take care of chapter 10 here for today. Wonderful work, everybody. Absolutely fantastic. You guys were on point today. I'm really proud of you guys. I'm really, really proud of you guys. You guys worked pretty fast. You guys were on top of things today. Very, very happy to see that. Very good to hear. Alright. Well, guys, thank you so much. Thank you guys so much for being absolutely fantastic with me today. You guys definitely knocked out of the park with these couple of examples. I think you guys are really, I think you guys have done really well here today. Love all you guys. All you guys are absolutely fantastic. And we're going to start with chapter 4 here for next time. So we are continuing to move forward. We're working through. All right. Everybody, I hope everybody has an absolutely fantastic night. We're going to come back in a couple of days. Again, you guys know where to find me. I'm on Discord or email. All right. If you'll feel free to ask me questions. All right. And yeah, we'll see you all in a couple days. All right. And as always, everybody, as always, stay safe, stay healthy, but most importantly, stay sane. All right. Everyone, take care of yourselves. All right, Horitz, Savvy, Maritza, Bill, Sanla, Strolling. Have a wonderful night, everyone. All right, take care of yourselves, and we'll see you in a couple days. All right, everybody, have a good one. See ya. Bye. Bye, everybody.